Good morning, students. We have already studied the introductory part of the chapter solution, which is the first chapter of class 12th chemistry in CBSE board. Now today we will proceed to the next topic, that is methods for expressing concentration of solutions. Before proceeding, let us know that what is concentration. So concentration is nothing but the amount of solute present in the given quantity of solution. Concentration is important. It has significance in many chemical reactions. For example, the titration process. Now, the first method to express the concentration is percentage. The concentration is expressed in percentage, and this percentage may be in terms of mass percent, volume percent, or mass by volume percent. Mass percent is expressed as W by W, volume percent, volume by volume, and mass by volume percent is expressed as W by V. Now, what is mass percent? Mass percent is the mass of the solute divided by the mass of the solution. Mass of the solution involves the mass of the solute plus mass of the solvent multiplied by 100. Volume percent is volume of a solute divided by volume of a solute plus volume of solvent multiplied by 100. This volume percent is used when the solute and solvent both are in liquid state, and the mass percent is used when both the solute and the solvent are in solid state. Now, in the percentage method, the third one is mass by volume percent. This method is used when the solute is in solid state and the solvent is in liquid state. So its formula is mass of the solute divided by volume of the solution into 100. Write it as 100. Now, the next method of expressing the concentration is parts per million, which is abbreviated as ppm. Let us consider a solute A present in very large volume of solution. For example, let us consider the sea. The amount of solute or amount of any salt which is dissolved in ocean or sea water is very, very small as compared to the total mass or total volume of the ocean. So it can be expressed as mass of the solute divided by total mass of the solution, because ocean is also a solution in which a very minute amount of solute or the solute is present in traces, that is in negligible quantity. Therefore, percentage method is not suitable here. Here, instead of multiplying by 100, we will multiply by million, that is 10 to the power 6. So only the difference between percentage and ppm method is that instead of putting 100 over here, million is put. This ppm method may also be expressed like percentage method. It may also be expressed in mass by mass ppm, volume by volume ppm, and mass by volume ppm. Generally, ppm method, parts per million, is used to express the pollution in sea water or in river water or in air, when the pollutant is in very trace quantity. For example, the amount of DDT, which is a pollutant in the sea water, will be always expressed in terms of parts per million, not in percentage. Now, next method of expressing the concentration is molarity. Molarity is nothing but number of moles of solute divided by volume of solution in liter. Note it down, when the volume is given in milliliter, then in the numerator, then the numerator should be multiplied with 1000, because the volume of solution should always be in liter. If it is not in liter, it is in milliliter, then milliliter must be converted into liter. Its disadvantage is that the molarity changes with the change in temperature. It is because it is number of moles of solute divided by volume of solution, and the volume is affected with the change in temperature, and therefore the molarity too will be affected. Its unit is number of moles per liter. That is moles per liter. Its unit is moles per liter. Unit of molarity. Mole per liter. Now the next method of expressing the concentration is molality. Molality involves number of moles of solute divided by mass of the solvent in kilogram. Note it down, if the mass of the solvent is in gram, then it must be converted into kg by multiplying the numerator with 1000, as we did earlier in case of molarity. It is advantageous over molarity that its value is not affected with the change in temperature, because it is number of moles of solute divided by mass of the solvent, and the mass is not affected by the change in temperature. Okay, students, now let us move to the next topic. Next method of expressing the concentration. A very important method of, yet another important method of expressing the concentration is mole fraction. Mole fraction is number of moles of component divided by total number of moles. For example, if you take the gaseous mixture, if you want to take a gaseous mixture and you want to express the concentration of any one component in it, then this method is very suitable, mole fraction. Mole fraction is number of moles of one component divided by total number of moles. That is, total number of moles means number of moles of one component plus number of moles of another component. Similarly, the mole fraction of the another component B can be calculated by dividing number of moles of that component divided by total number of moles of the mixture. Always the sum of the mole fractions is equal to unity. It is not necessary to find out the mole fraction of both the components. If you know the mole fraction of any one component, then the mole fraction of the another component can be calculated by this equation. that is subtracting the number of moles of the other component by 1. That is, if we want to calculate the number of moles of the second component, then subtract the number of moles of the known component or calculated component by 1. Now next method of expressing the concentration is normality. Normality is number of gram equivalents divided by volume of solution in liter. Again, I will repeat that if the volume of solution is in milliliter, then multiply the numerator with 1000. Now what is gram equivalent? Number of gram equivalents is equal to mass of solute divided by equivalent mass. Now what is equivalent mass? Equivalent mass of any metal is equal to atomic mass upon its valency. Equivalent mass of any salt is equal to formula mass divided by oxidation number of the metal. Equivalent mass of any acid is equal to molecular mass divided by its basicity. Equivalent mass of any base is equal to molecular mass divided by acidity. Now, the last method of expressing the concentration is formality. Formality is equal to number of moles of solute divided by volume of solution in liter. If it is in milliliter, then multiply the numerator by 100. Now, if in any question, in any numerical, the molarity, if you are asked to calculate the molarity when density of the solution is given along with percentage of solute dissolved, then molarity is equal to mass percent of solute multiplied by density of the solution into 10 upon molecular mass of the solute. Because in your exercise, in text question, you will come across such numericals where the density of the solution will be given along with the percentage of the solute. So this is all for today's topic, and the next topic, solubility, I will teach you tomorrow at the same time. Okay, thank you. If you have any doubt, you please post your questions, your queries, and I will try to solve your queries, problem to my full potential. Okay, thank you.